Good afternoon, everyone. Thank you for the nice talk, Rajat. Talking about AI and Copilot challenges, we'll continue the theme and we'll crank it up a notch by solving all these problems by building our own Copilot. So today, that's what we want to talk about, how we went ahead about building a Copilot for Freshworks developers that build apps for our marketplaces. Quick show of hands. How many of you have heard of this term called RAG or Retrieval Augmented Generation? Amazing. And how many here are actually building LLM powered products? Wow, nice. So I hope you like this talk. Just for intro, I'm Neeraj. I lead Freddy Copilot for Freshworks as a product lead and all their AI initiatives. And I have with me Naveen, who is, again, a lead software engineer with Freshworks Marketplace. The way I'm going to go about this talk is first give you a quick bit of introduction about what our marketplace and developer platform is, and then let you experience the Copilot we have built that makes it very easy for any developer to go from an idea all the way to an app code in a very conversational manner. And then we'll go and talk about how exactly we built this Copilot and what was the engineering and science and the decisions we took behind it. A lot of it is about prompt engineering. A lot of it is about building our own knowledge base, and that prevents you a lot of challenges that my previous speaker talked about in terms of your LLM lock-in and building great prompts. A quick view about what Freshworks is. We have 65,000 plus customers, north of 600 million revenue, and we work with a lot of brands across industries. And the interesting thing is all these brands and companies, they not only use one or more of the Freshworks products, but they come with a lot of custom use cases, whether in the form of integrations that they want to do across their other products or their specific long-tail use cases that we expect developers to come and build apps on a marketplace and be able to solve it. This is what, at a high level, Freshworks portfolio is. I'm sure you've heard of Freshdesk, which is a famous customer support software. And we have products across IT service management like Freshservice and so on. Behind the scenes, we have a marketplace which allows our developers to build and publish apps on this marketplace that have a ready audience of 65,000 plus and provides a very good opportunity for the developers to come and build and publish their apps and essentially let the customers use it. As you can see, a lot of these apps are like tier 1 integrations with tools like Google, Slack, and so on. But some interesting ones, for example, here we have Iris Agent, which basically uses this service desk software and AI to be able to automate a lot of customer service agent tasks and so on. So there are a lot of opportunities here. And the developers can use AI to essentially build on top of it. Now on to our main topic. When we heard about and when we were looking at how this AI innovation is happening and essentially how the development is becoming more conversational, we were very excited because I believe AI essentially unlocks developers to come with their creativity and not be challenged by their current knowledge or limitations. So we figured out how we are going to conceptualize building a Copilot that our developers can use to build apps and publish on marketplaces. So that was the vision we took, that how do we enable developers to build high quality apps in a very rapid fashion, in a very fast and iterative fashion. We started with a beta release, and we already have 1,000 plus installed as a VS Code plugin. Yeah. So the way we conceptualize this is how do you, as a developer, come with an idea, and how can we take you in a very conversational, natural fashion, transform the whole SDLC process, right? So it's a very natural process that you think about an idea, you gather, you understand the developer, APIs, platform, and then you go about designing the mockups and so on, and then you work, you implement, and you keep refactoring it to the point where you feel comfortable to hand it over to testing or test yourself and release it. So the way we conceptualized is we work backwards to this SDLC and looked at everything that developers do and how do we augment it using AI. Everything grounded in the Freshworks context. So I'm going to give you a quick overview of how the Copilot looks. So for example, if you are building an app, let's say a simple URL shortener app, and for Freshdesk or Freshservice, you simply come with your idea and you provide an instruction. The better the instruction that you provide to the Copilot, as we all know, the better the output will be. And essentially you talk about, hey, I want to build this app, and these are some of the features that we want to build in this particular app. What we do is, as Copilot, we take this use case and try to understand the construct behind the app. And these are some of the concepts you can use. So for example, a construct is essentially, here, as you can see, that Copilot has automatically understood that which kind of products, Freshworks products or product modules that this app needs, all from the use case, right? And we're going to talk about how we actually build this retrieval augmented or RAG pipeline to enable this. And one of the key principles we use in any AI-powered products is called developer in the loop and control. So any decisions we take on the behalf of developer, like choosing the products or choosing where the app will appear, all of it is in consultation with the developer. So I'm sure you are seeing like GitHub Copilot Workspace and so on. All of these AI products needs to be built in a fashion that developers are always in control and they're able to edit and review and so on. So here we have already selected some of the product modules auto-detected from the use case. And slowly from this, we next talk about, okay, where this app is going to appear, right? So for example, this app is going to appear in a Freshdesk ticket sidebar. And essentially, we also provide a complete design to front-end code automation. What it allows is we have created a pipeline that can take a simple image, and we understand the components, the layout, and the style of these components, and are able to build a complete front-end HTML, CSS code today. We use some of these vision models like Gemini and GPT are very good at understanding this image. And this is a very simple example, but we can build more and more complex UI using our Copilot. Once we understand the construct of the app, the platform features that it's going to use, then we essentially generate the complete app code. This is, you can say, up to 50, 60, 70% of the structure and the scaffolding of the code is generated. And then essentially you can just simply run this app or iterate on top of it. And we also provide features for debugging, for refactoring your code, and so on. So this is a quick overview of how you come with your idea, and the Copilot works with you, and without even understanding in deeper fashion what Freshworks platform is or what are the intricacies of a developer platform, you can just go from an idea to an app code in a very simplified fashion and a very conversational fashion. So this is how the app would appear on a Freshdesk ticket sidebar and essentially work. So this is all AI generated, and obviously the more complex your use case is, the more you have to do iterations with the Copilot. Moving on, we talked about like some of the different features we provide going from an idea to code in a conversational manner. We also talked about how we build this whole design to code pipeline. So if you've not used some of the key vision models like Gemini and GPT, new vision models, please do. We built our pipeline in a way that it can take a mock-up image or a Figma URL, and essentially we are able to understand what components and style and layout. And these components are like Freshworks components. So again, all the Copilot that is generates, it is all grounded in the Freshworks developer platform context. And you can just replace it with like Apple platform or any other platform, right? So that's how this Copilot works. And when you generate app code, obviously there's going to be a lot of iterations, right? So we looked at that part of the SDLC also. So for example, if you're facing any error, you simply right-click, paste it into the chat, and it will not only solve, it will give you the root cause, but actually understand your app context and solve the problem, and you can simply insert the code and work forward. All of this without, again, switching context to documentations or communities. You can just be right in your IDE and keep working on your app idea. Now, all of this is about what was built and how we conceptualize. I'll call upon Naveen to actually talk about how we built behind the scenes this RAG pipeline, this retrieval augmented generation pipeline, and I'll encourage everyone to explore yourselves as well.
Yeah, hi everyone. So, I guess now everyone has a basic understanding of what Freddy Copilot is and how it helps the app developers of Freshworks Marketplace to publish their apps in Marketplace in a more quicker manner, right? So now let's dive into the more interesting part of this discussion, wherein we will discuss the technology behind this Freddy Copilot and how we built it in the backend, right? Yeah. So the core problem which we are trying to solve here is, so for any user or developer query, right? So if you are able to get an accurate and proper response, so we will be able to implement all the features which we have discussed so far. Let it be the taking a use case and generating the app code, or let it be a conversation wherein we try to fix an app issue, right? So it's all a developer or a user query. So if you are able to take that developer or user query, and if you are able to generate a proper and accurate response in a quicker and cost-efficient manner, that is what we are trying to solve, right? That is our core problem. So how are we solving this? So the first and most obvious way would be to directly use the LLMs, some of the LLMs which are currently available in the market. For example, let's say the GPT or Facebook's Llama, all those LLMs, those are publicly available and those are well built. So why don't we directly use them and directly pass the developer query to the LLM model and get the response and give it back to the developer, right? So this works, but it has its own challenges, which we will discuss. So most of these LLM models which are available in the market, right? So these are trained with the older data. These are not trained with the newer data. So for example, let's say if I am releasing a feature today, and there are a lot of Freddy Copilot clients who are using our VS Code extension, right? So if they come tomorrow and query about this feature, it won't be able to answer because these LLMs will not be trained on that feature because we have released it yesterday and and obviously it will not be trained on that data, right? So that is one of the problem which we will face if we use the models which are available in the open market. And the other is the complete lack of knowledge on Freshworks ecosystem. So the responses will be more accurate if we try to give more Freshworks context to the Freddy Copilot. So if your model is more and more generic, the responses will also be generic and it will not be tailor-made for Freshworks context. So that is one thing. And we also have something called as FDK. So FDK is nothing but Freshworks development kit, which helps in, which is used for development of Freshworks apps in your local. So it is just a command line tool. So don't get confused between Freddy Copilot and FDK. So FDK is a command line tool wherein Freddy Copilot is a AI assistant wherein which assists you in development. But FDK is compulsory and it is needed for your Freshworks apps development. So this FDK, right? It is in different versions. It has evolved over the period of time. And we have a lot of clients which are still using the older versions of FDKs. So for the clients who are using the older versions, we should be able to respond in their own context. So we should not suggest them the newer features which are there. We should only suggest the features which are supported by the older version. So the FDK context plays an important role in giving an accurate and proper responses to the client. So how do we solve these problems and give context to this pipeline, right? So this is how we solve it. So we introduce this FDK context into the pipeline. FDK context is nothing but a combination of Freshworks developer documents, documents about APIs, about Freshworks products, and a few common code snippets which are used to solve common issues, right? So the combination of all this, we call it as FDK context. What we do generally is we take all this FDK context, we convert it to hundreds of articles, and each article, right, we pass through an embedding model. So while passing through this embedding model, what we essentially do is we convert each of these article into a vector. So all these hundreds of articles and these hundreds of vectors, this will be saved in the vector DB. So this is what we call as preloading. We have loaded all our FDK context into the vector DB and we have it ready to be queried, right? So now whenever a developer queries, so what we do is we essentially take this developer query, we convert this developer query into the vector using the same embedding model which we used during the preloading phase. Now what we do is out of this vector we got from the developer query, we try to find the matching vectors by scanning through the DB. So let's say we get top n results while scanning through the DB. So out of this top n vectors, we find the corresponding articles for those vectors. So essentially what we are doing here is, for a single, for any developer or user query, we are finding the related articles. So this is what we call as context augmentation for a particular developer query. So once we have this context augmented for a particular developer query, we build a prompt by using both the developer query and the context which we got for it. So a lot of iterations go in optimizing this prompt. A lot of engineering goes into it, where we have multiple iterations in tuning this prompt so that LLM will be able to give an accurate answer. So once we have that prompt ready, and we feed in the developer query and the context selected to it, and if we pass this prompt to LLM, it will be able to give more accurate and a deterministic answer for whatever the query which we feed in. So this looks fine, right? What are the challenges with it? So the most important and the challenge which we are facing is we should always keep this vector DB updated. So let's say we are releasing a new feature today, and this release, along with, we should have an automated pipeline wherein we should also update this FDK context and vector DB with the new feature and the docs related to it, so that whenever a client comes and queries through Freddy Copilot, right, he will be able to get the context out of it, and Freddy Copilot will be able to answer out of it. So this all works fine. So this was all working fine for us for smaller queries, but when it came to larger queries, right, this was not performing good. So when we analyze deeper, so if you are wondering what a prompt is, this is how a prompt looks. Yeah. So coming back to larger queries problem, wherein we were not getting accurate answers. So when we analyzed deeper, we found out for larger queries, the embedding model is truncating the query, and it is only taking the first part of it, and it is ignoring the last part of it. So how we approached the problem is, we introduced something called as text processor in between developer query and the vector DB. So what it essentially does is, it uses NLP to segment the developer query into multiple segments. So let's say I have got a developer query of 300 words. It will divide it into 3 segments, let's say. It is all based on NLP, and it will divide it into appropriate number of segments. So for each segment, we will assign a score. And based on the score, we will augment the context for this segment. Earlier, we used to augment context directly based on the developer query, but here we divide the developer query into segments, and for each segment, we will augment the context for each segment. So by combining all the context for these segments, right, that is what is essentially the developer query, right? Developer query context. So here, the advantage is, even if there is some important information mentioned in the last part of the query, that will also be considered while we feed in the context to the LLM. So once we have the prompt ready, it again follows the same pipeline wherein we feed into LLM, and we will be able to get an accurate response from the LLM. Yeah, by this, we will have accurate response than the earlier version which we discussed. So we were discussing a lot about embedding model during both the preloading phase and during the querying phase, right? So what is the embedding model which we are essentially using? So mini-LM is the embedding model which we are using. So the reasons are basically it does effective vectorization. So which essentially means it basically groups the related articles together. So whenever a developer query comes in, it is able to efficiently pick the related articles. So that's what we mean by efficient vectorization. And we have to give real-time responses to the user. So if you have gone through the demo of Freddy Copilot, the user would be expecting the answers in the chat window, right? We can't make the users wait for very long. We should be giving the answers to the user in less than 5 seconds. So that is what we achieved with mini-LM. And also the cost effectiveness. It takes a very less amount of infra to get this mini-LM up and running. So which in turn translates to cost effectiveness, right? So that's what it is all about. And when we were going through the pipeline, I was explaining a lot about the preloading the data to VectorDB, right? So how we do it. So we will go a little deeper into it on how we do it. So whatever the FDK context I was mentioning is the left part, which is the docs, APIs, and the code snippets. So the docs are nothing but the Freshworks developer docs, and the APIs are nothing but Freshworks APIs, third-party APIs docs, and also mainly the platform APIs. And the code snippets are nothing but the common issues with which the developer faces, and also some of the snippets from the community which we have. All those things will be converted into articles using this text processor, and then these articles we will be passing through the embedding model as I explained earlier, and we will be converting that to vectors, and we will be saving that vectors in the VectorDB. So this is what we discussed in the preloading phase. I just wanted to dive a little deeper into it. Yeah, that's about the technical background of how we get accurate answers for developer queries in Freddy Copilot. Let me again hand it over back to Neeraj to wind up the talk. Thank you.
Thanks, Navin. Thank you. I'll just wind it up. So quickly, take your prompts seriously. Build your data pipeline. Make sure your knowledge base is up to date. Being able to retrieve the right context from this knowledge base and able to create your prompts and pass it to LLM is what makes the difference of a lot of challenges that we were solving. We got a great traction from our developers. We've already burned 47 million plus tokens and a lot of thousands of dollars, and more than 330 plus apps have been built using Copilot. Yeah, thank you so much. If you want to, we have a booth. If you want to hear about more war stories from building our own Copilot, or if you're building LLM-powered products, please do come and talk to us. Here's a QR code for a quick quiz if you want to take it. Thank you. Thank you, everyone.